You've probably been told that medieval people thought the Earth was flat. It's one of history's most persistent stories. Medieval Europeans, according to popular memory, believed they lived on a disk suspended in space, terrified that ships sailing too far would plummet off the edge into an abyss. Columbus proved them wrong. The Church suppressed the truth. Brave explorers defied religious dogma and discovered a spherical world. It's a compelling narrative. It fits perfectly into the story we tell ourselves about progress, about how science and reason eventually triumph over ignorance and superstition. It separates the dark medieval period from the enlightened modern era. It makes us feel superior to our ancestors, and it is almost completely false. The uncomfortable truth is this: educated medieval people knew the Earth was round. They had known it for over 2,000 years. Ancient Greek mathematicians had proven it. Medieval scholars had read those proofs. The spherical Earth was not a discovery waiting to happen in 1492. It was established knowledge that had been taught in universities, monasteries, and cathedral schools throughout the Middle Ages. The real story is far more interesting than the myth, and it tells us something important about how we construct historical narratives to serve modern purposes. Let's start with the ancient foundations, because understanding where this knowledge came from helps explain why it never really went away. Around the 6th century BCE, Greek philosophers began thinking systematically about the shape of the Earth. Early thinkers like Thales and Anaximander proposed various models, but they were largely speculative. Then came mathematics and observation. By the 4th century BCE, evidence began to accumulate. Aristotle, writing in the 300s BCE, presented several arguments for a spherical Earth. He noted that ships disappear hull first over the horizon, suggesting a curved surface. He observed that different stars were visible from different latitudes. He pointed out that during lunar eclipses, the shadow cast by Earth on the moon was always circular, regardless of the moon's position in the sky. A flat object would cast different shaped shadows depending on its orientation. Only a sphere casts a circular shadow from all angles. These observations were not vague philosophical musings. They were repeatable, testable, and logically sound. Aristotle's arguments were so compelling that the spherical Earth became the dominant model among educated people in the ancient world. A few decades later, Eratosthenes, a librarian in Alexandria, went further. He didn't just accept that the Earth was round. He measured it. He observed that at noon on the summer solstice in Syene, the sun shone directly down a deep well, casting no shadow. On the same day in Alexandria, hundreds of miles north, the sun cast a shadow. Using the angle of that shadow and the known distance between the cities, Eratosthenes calculated the Earth's circumference. His measurement was remarkably accurate, off by only about 5% from modern calculations. This happened in the 3rd century BCE. We're talking about 2,300 years before Columbus. This knowledge didn't disappear when the Roman Empire fell. It was preserved, transmitted, and actively taught throughout the medieval period. Medieval scholars inherited the classical texts. They read Aristotle. They read Pliny the Elder. They read Macrobius, a 4th century Roman scholar who wrote extensively about the spherical Earth. They read Boethius, a 6th century Roman philosopher and Christian who explained the globe model. These weren't obscure texts hidden in lost libraries. They were widely copied and studied. Monasteries, which were among the few institutions maintaining literacy during the early medieval period, preserved these works and passed them along. By the High Middle Ages, the spherical Earth was standard doctrine in European universities. When Thomas Aquinas wrote in the 13th century, he discussed the Earth's shape as an established fact, not a controversial proposition. When Dante Alighieri wrote the Divine Comedy at the beginning of the 14th century, He placed hell at the center of a spherical Earth, with the rest of the cosmos arranged in concentric spheres around it. He was not inventing this model. He was using the accepted cosmology of his time. Medieval theologians debated many things about the Earth and cosmos, but its spherical shape was not among the serious points of contention. It was basic knowledge. The medieval church, far from suppressing this understanding, actively promoted it. Christian theology had to accommodate the spherical Earth because the text they were working with, inherited from the classical world, assumed it. Church scholars explained how a spherical Earth was consistent with Christian doctrine. They pointed out that God's creation was orderly and perfect, and the sphere was the perfect geometric form. They noted that the spherical Earth allowed for a meaningful cosmos in which heaven was above and hell was below, regardless of where you stood on the surface. The idea that the church opposed the spherical Earth model is not just false, it's backwards. The church integrated that model into its theological framework. So where does the flat Earth myth come from? How did this false idea become so dominant in popular understanding? The answer is surprisingly recent and deeply connected to how we construct historical narratives to serve present-day purposes. The myth of the flat Earth Middle Ages was largely invented in the 19th century. It became popular through a specific book published in 1874, Irving Washington's The Life and Voyages of Christopher Columbus, a biography that became the standard popular account of Columbus for generations. Washington was not a historian in the modern sense. He was a writer, and he had an agenda. He wanted to present Columbus as a heroic figure who defied a superstitious and ignorant establishment. To do this, he invented a version of the medieval world in which flat Earth belief was universal and unquestioned. Washington based his narrative on selective reading and outright misinterpretation of sources. When medieval texts expressed uncertainty about specific geographical details, he interpreted this as uncertainty about the basic shape of the Earth. When medieval thinkers debated the size of the Earth, or the extent of oceans, or the location of distant lands, he presented these as debates about whether the Earth was round at all. He took stray comments, often from figures on the margins of scholarly discourse, and presented them as mainstream medieval thought. He ignored the dozens of medieval sources that clearly affirmed the spherical Earth, and he created a compelling narrative, courageous explorer versus ignorant masses and superstitious clergy. This narrative was enormously appealing. It fit perfectly into 19th century ideas about progress, about how the world had been dark and ignorant and gradually became enlightened through reason and science. It provided a satisfying story of conflict between faith and reason, even though that conflict was largely imaginary. It allowed modern readers to feel superior to medieval people, and it was repeated so often in textbooks and popular histories, and eventually in educational systems, that it became accepted as fact. But there's something else going on here too, something about American identity and myth-making. Irving Washington wasn't just interested in accurate history. He was interested in American myth. Columbus represented the American spirit to him, the spirit of the bold individual who ventures into unknown territory and transforms the world through courage and vision. The flat Earth opposition represented all the forces that would resist such transformation: European superstition, religious dogmatism, institutional conservatism. By inventing the flat Earth Middle Ages, Washington was creating a mythological backdrop against which the American project of exploration and progress could be heroically positioned. This myth persisted for over a century because it was useful. It was useful to educators who wanted to promote science and reason. It was useful to anti-religious thinkers who wanted to present religion as inherently opposed to scientific progress. It was useful to popular writers who wanted a good story. It was useful to Americans who wanted to understand themselves as pioneers of progress in a way that flattered their self-image. The myth didn't persist because it was true. It persisted because people had reasons to keep repeating it. To understand the real medieval understanding of the Earth, we need to step away from the flat Earth debate entirely and look at what medieval scholars actually spent their time arguing about. They didn't argue about whether the Earth was round. They argued about what was on it, how big it was, what lay beyond the known world, and how to interpret ancient texts that sometimes contradicted each other about geographical details. Medieval cosmology was sophisticated and mathematically rigorous. The Standard Model, which dominated from roughly the 12th century onward, was based on a spherical Earth at the center of concentric spheres representing the orbits of the Moon, Sun, planets, and stars. This model came from Aristotle and had been elaborated by medieval Islamic scholars, particularly al-Ghazali and others who worked in the great translation centers where Greek and Roman texts were preserved and developed. European scholars encountered these works through contact with the Islamic world, particularly through Spain and Sicily, where Christian, Muslim, and Jewish scholars worked in close proximity. The spherical Earth model was not just accepted passively. Medieval thinkers engaged with it actively, tried to understand it, and worked out how it functioned. In the 12th century, scholars at cathedral schools and the newly emerging universities debated the details of this model. If the Earth was a sphere, how did people on the underside not fall off? Medieval scholars solved this problem by appeal to gravity, understood not as a force, but as a natural tendency of heavy objects to move toward the center of the sphere. Every point on a sphere's surface is up relative to the center and down relative to the surface, so people on every part of the sphere would experience themselves as right side up. This is actually correct. Medieval scholars had figured this out through logical reasoning based on the accepted model. One of the most important medieval texts about geography and cosmology was the Imago Mundi, written by Pierre Daly in the 14th century. This text was widely copied and read. It clearly describes the Earth as a sphere. It discusses the distribution of land and water on that sphere. It addresses questions about the habitability of different regions. It was not a fringe work. It was mainstream medieval learning. Columbus himself owned a copy and annotated it. The existence of this text, widely distributed and clearly indicating a spherical Earth, makes the claim that educated people of Columbus's era believed in a flat Earth simply untenable. Medieval scholars did have genuine disagreements about geography, but these disagreements concerned different questions. One major debate involved the extent and distribution of water and land. Ancient texts suggested that most of the Earth's surface was covered with ocean, with only a few islands or narrow corridors of land. Some medieval thinkers accepted this view. Others, based on indirect evidence and logical reasoning, argued that there must be more land than was shown in ancient maps. This debate actually turned on a real geographical question: how much of the Earth's surface is water and how much is land? Medieval scholars couldn't answer this question with certainty because they simply didn't have enough observational data about the parts of the world known to Europeans. This debate mattered because it affected how people thought about navigation and exploration. If you believed that the Earth was completely surrounded by ocean with no land masses in between, long-distance ocean voyages seemed impossibly dangerous. If you believed there might be islands or continents, such voyages seemed more feasible. Columbus himself was influenced by certain medieval geographical theories that suggested Asia might be closer to Europe than the ancient sources indicated. He believed, based on selective reading of medieval geographical texts, that he could reach Asia by sailing west. He was wrong about the distance, and he was very lucky that the Americas happened to be where they were, because otherwise his crew would have run out of supplies long before reaching Asia. But notice what this shows us. Educated people of Columbus's era, including Columbus himself, were not debating whether the Earth was round. They were debating how far it was around and what lay in between. Even the geographical error that nearly killed Columbus's expedition was premised on the accepted fact of the spherical Earth. He miscalculated the circumference, not the shape. If Columbus, or any educated person of his time, had seriously believed the Earth was flat, the entire enterprise would have been dismissed as impossible from the start. You can't reach the other side of a flat disk by sailing in one direction. The very possibility of Columbus's voyage demonstrates that his contemporaries, including the Spanish monarchs who funded him, accepted the spherical Earth model. The real geographical ignorance of the medieval and early modern period wasn't about the Earth's shape. It was about what was actually out there. Europeans knew almost nothing about the vast majority of the world's surface. They had some knowledge of Africa, partial knowledge of Asia gained through limited trade contacts, and no knowledge whatsoever of the Americas. Filling in this map and discovering what lay beyond the known world was indeed a great challenge, and explorers who undertook it were brave. But they weren't brave because they were sailing against the consensus belief that the Earth was flat. They were brave because they were sailing into unknown territory where unknown dangers waited. The medieval understanding of the Earth's size was another area of genuine debate and uncertainty. Eratosthenes had calculated the circumference, but not all medieval scholars accepted his figure. Some thought the Earth was smaller than Eratosthenes had calculated. This actually made long voyages seem more feasible, because a smaller Earth meant the distance to Asia by sailing west would be less. Columbus's calculations, which suggested a smaller circumference than we now know to be accurate, made his proposed voyage seem more reasonable to contemporary scholars. Again, notice that this entire debate takes the spherical Earth as its foundation. The only variable is size. There were a few medieval thinkers who expressed skepticism about certain aspects of the spherical Earth model, or who emphasized the practical difficulties it created for understanding human geography and the distribution of populations. But even these thinkers did not deny the spherical shape. At most, they noted that if the Earth was truly spherical and covered with water, with only narrow habitable zones, then the distribution of people and civilizations required explanation. Medieval theology addressed this by relying on God's design and divine providence. God had arranged the Earth and populated it in a way that served his purposes. The shape of the Earth was not in doubt. The challenge was theological and practical, not physical. One figure who is sometimes cited as evidence of medieval flat Earth belief is Cosmas Indicopleustes, a 6th century Christian geographer. Cosmas described the world as a flat rectangle, with the heavens as a vault above it. He rejected the spherical model explicitly. This seems like evidence of flat Earth belief. But Cosmas was writing in the 6th century, at a time when Greek learning was fragmenting in the Western Roman Empire, though it remained more intact in the Eastern Roman Empire. Even more importantly, Cosmas was not representative of medieval thought. He was an anomaly. His works were known to medieval scholars, but primarily because they had been preserved, not because they represented the mainstream position. Medieval scholars read Cosmas as an example of outdated thinking, not as an authority to be followed. The irony is that the flat Earth myth itself is partly based on selective and distorted readings of sources, much like Irving Washington's earlier work. Modern scholars and popular writers, trying to make the case that medieval people believed in a flat Earth, have pointed to Cosmas as evidence. ignoring the fact that he was an outlier even in his own time, and certainly not representative of the medieval synthesis of Aristotelian physics and Christian theology that dominated the later medieval universities. Understanding how the flat Earth myth actually became established in popular consciousness requires looking at the 19th century historians and writers who created it, and understanding why they had incentives to do so. Irving Washington was not an honest scholar working to uncover the truth about medieval beliefs. He was a writer constructing a narrative, and he knew what narrative would sell. Washington wrote in the context of 19th century American intellectual life, which was intensely invested in establishing a narrative of progress and enlightenment. The scientific revolution and subsequent technological advancement had transformed European and American societies. Industrialization, mechanization, and scientific method seemed to promise unlimited progress. In this context, many thinkers wanted to explain how this progress had come about. Where had it come from? How had humanity escaped from ignorance to knowledge? One influential answer was provided by the conflict thesis between science and religion. According to this narrative, which was especially popular among scientifically minded thinkers and anti-clerical intellectuals, the Church had dominated medieval thought and suppressed scientific progress. Religion and science were locked in perpetual conflict. The scientific revolution represented the triumph of reason and observation over religious dogmatism. Science progressed precisely to the extent that it broke free from religious control. This narrative was seductive and useful for multiple reasons. For scientists, it explained their own importance and the progress they represented. For secular thinkers and those skeptical of religion, it provided a powerful argument against religious authority. For Americans constructing a national identity, it suggested that the American project itself, founded on Enlightenment principles and skeptical of European religious traditions, was on the right side of history. The flat Earth myth fit perfectly into this narrative. Here was a supposedly scientific fact that the medieval church had suppressed. Here was medieval ignorance contrasted with modern knowledge. Here were brave explorers and scientists fighting against religious superstition. Columbus was the perfect figure to symbolize this conflict. An explorer whose voyage supposedly vindicated scientific truth against religious dogmatism. An individual challenging an institutional order, a representative of progress overcoming resistance from tradition. The problem was that nearly every element of this story was false. Columbus was not fighting the Catholic Church. The Spanish monarchs who funded him were deeply pious Catholics, and the Church had no theological objection to the spherical Earth or to Columbus's voyage. Columbus was not vindicated by discovering a flat Earth-denying institution was wrong, because there was no such institution. He was, however, lucky because his calculations about distances were wrong, and the Americas happened to be where he sailed. He found land when he expected to find ocean. This was fortunate, but it wasn't a triumph of reason over superstition. But Washington's narrative was so powerful, so useful for the purposes to which it was put, that it became embedded in American education and culture. By the early 20th century, the myth was taught as fact in schools. It appeared in textbooks. It was repeated in popular histories. Academic historians who knew better often didn't bother to correct it, partly because it seemed like a minor point, partly because the myth had become so established that challenging it seemed like swimming against a strong current. The real scandal, from a historical perspective, is not that medieval people thought the Earth was flat. It's that educated modern people, with access to far better sources and more sophisticated methods of historical research, continued to assert something that was demonstrably false. The persistence of the myth represents a failure of historical literacy. It shows how easily false narratives can become established, how powerful storytelling can be compared to careful evidence-based research, and how useful myths can be even when we know them to be false. In the 20th century, some historians did begin to push back against the myth. Andrew Dickson White, a historian of the conflict between science and religion, actually did extensive research and discovered that the flat Earth narrative was largely invented. He tried to correct the record, explaining that medieval people had known the Earth was round. But by this point, the myth was too established in popular culture to be easily dislodged. White's scholarship was read by other historians but didn't significantly change public understanding. The myth persisted even as historians increasingly rejected it. This created an odd situation where scholarly consensus and popular understanding drifted further and further apart. Modern historians, looking at the actual medieval sources, consistently concluded that educated medieval people believed in a spherical Earth. But in popular culture, the flat Earth Middle Ages remained the default assumption. When people heard about the Middle Ages, they thought of darkness, superstition, and ignorance. The flat Earth was simply part of that package. The myth was also sustained by the way it was embedded in science education and the history of science. Many science textbooks wanted to tell a story of scientific progress, of how we moved from superstition to knowledge. The flat Earth Middle Ages provided a convenient historical backdrop. It gave students a sense of how far we've come, a feeling of superiority to our ancestors, a validation of the scientific method as a triumph over ignorance. It was useful pedagogically, even if it was false. Teachers were repeating something they had learned as students, something that appeared in their textbooks, something that seemed to make a good point about the superiority of modern science. The myth was also sustained by popular media. Numerous films and television shows depicted medieval people as believers in a flat Earth. When Columbus was portrayed in films, he was often shown arguing with flat Earth believers. This imagery was so powerful and emotionally resonant that it shaped public understanding more effectively than academic corrections could. People remember what they see on screen more easily than they remember what they read in scholarly journals. The cinematic flat Earth Middle Ages became more real to the average person than the actual, historically accurate medieval understanding of cosmology. This phenomenon illustrates something important about how historical myths develop and persist. They persist not because there's a grand conspiracy to suppress truth, but because myths are more emotionally satisfying than reality, more useful for constructing certain narratives, easier to remember and repeat, and more compelling as stories. The truth about medieval cosmology, while genuinely interesting to a historian, doesn't have the dramatic punch of David against Goliath, of an individual standing against an ignorant mob, of progress triumphing over superstition. What's also worth noting is that the 19th century creation of this myth tells us something about the 19th century itself, not about the medieval period. The fact that Victorian and American writers felt the need to invent a dark medieval past against which to contrast their own enlightened present reveals their anxieties and their values. They wanted to believe in progress. They wanted to believe that religion and science were fundamentally opposed. They wanted Columbus to be a hero against ignorant masses. These desires shaped what historians they read, which sources they emphasized, and ultimately which myths they created and repeated. So what's the actual relationship between medieval knowledge and the spherical Earth, and why does this matter for how we understand history? The truth is far more complex and interesting than the myth, and it reveals something important about how knowledge develops and spreads. Medieval scholars did not discover that the Earth was round. They inherited this knowledge from ancient sources. But they didn't simply accept it passively. They engaged with it, questioned it, tested it against other evidence, and tried to understand how it worked. Medieval cosmology, far from being superstitious nonsense, was a serious intellectual endeavor. Medieval thinkers used logic and observation to defend the spherical Earth model. They worked out the mathematics of how gravity would function on a sphere. They debated the implications for human geography and habitability. They integrated this model into Christian theology in a way that made sense. What medieval scholars lacked was not knowledge of the Earth's shape, but knowledge of what was actually on the Earth. They had decent maps of Europe and some knowledge of Africa and Asia based on limited trade contacts. But the vast majority of the Earth's surface was unknown to them. This wasn't a failure of their cosmological model. It was a limitation of their geographical knowledge and their ability to travel. It took centuries of exploration, technological development in navigation and shipbuilding, and the creation of new trade routes before Europeans could begin to map the world more comprehensively. Columbus's voyage and subsequent age of exploration were important for geographical knowledge. They filled in maps. They revealed the existence of an entire continent unknown to Europeans. They demonstrated that the world was much larger and more complex than previously imagined. But none of this depended on proving that the Earth was round. The Earth's shape had been established knowledge for centuries before Columbus set sail. What the age of exploration did was reveal the actual distribution of land and water on that sphere. It transformed geographical knowledge, not cosmological knowledge. The medieval synthesis of Aristotelian cosmology and Christian theology was not a permanent achievement, though. Over the 16th and 17th centuries, a new cosmological model emerged, heliocentrism, the idea that the Earth orbits the Sun, not the Sun orbiting the Earth. This was a genuinely revolutionary change. It challenged not just medieval cosmology but medieval theology, because medieval theologians had integrated the geocentric model into Christian doctrine. Heliocentrism represented a real conflict between scientific discovery and established religious authority. This genuine conflict in the 16th and 17th centuries was later projected backward onto the medieval period. The scientific revolution became a story of reason triumphing over religion. And the medieval period, which came before the scientific revolution, was imagined as even more superstitious and ignorant than it actually was. The invention of the flat Earth Middle Ages was part of this backward projection. It created a symmetrical narrative: medieval darkness, Renaissance light, scientific revolution. But the actual medieval understanding of the Earth's shape doesn't fit this narrative, so the myth was invented to make it fit. This tells us something important about how we create historical narratives. We tend to project current concerns and conflicts backward into history. We imagine that the conflicts that matter to us now have always mattered. We construct stories that position us on the right side of a conflict between progress and stagnation, enlightenment and superstition, reason and faith. We invent history to serve these narratives, often without realizing that's what we're doing. The flat Earth myth is an example of this process at work. The persistence of the myth also reveals something about the power of education and intellectual tradition. Once something is taught in schools, once it appears in textbooks, once it's repeated by teachers to generation after generation of students, it becomes accepted as fact. The standards for what counts as knowledge are not as high as we might like. We don't test every fact we teach. We don't routinely check our educational materials against the latest scholarly research. We often teach what we were taught, what appears in books, what seems like common sense. The flat Earth myth persisted in education for over a century after historians had largely abandoned it, because the institutional machinery of education moved slowly. Understanding that the flat Earth myth is false changes how we should think about medieval knowledge and medieval Christianity. Medieval scholars were not opponents of learning. They actively engaged with the inherited texts of the classical world. They read Aristotle. They read Pliny. They debated and discussed these texts. They tried to understand and integrate classical knowledge with Christian theology. Universities developed in the medieval period in places like Bologna and Paris and Oxford, specifically to preserve and transmit knowledge. The medieval church was, in many places and times, a patron of learning and scholarship. This doesn't mean the medieval period was identical to the modern period, or that medieval scholars had all the knowledge we have now. They didn't. They had limited access to the globe, limited technology for observation, limited mathematical tools. But these limitations were about opportunity and technology, not about fundamental stupidity or hostility to knowledge. Medieval scholars worked with what they had. The myth of the flat Earth medieval world has also influenced how we think about science and religion. If we believe that medieval religious authorities suppressed knowledge of the spherical Earth, we might conclude that religion is fundamentally opposed to science. But this conclusion isn't supported by the actual history. Medieval religious authorities, far from suppressing knowledge of the spherical Earth, had integrated it into their theology. Some medieval thinkers did resist certain aspects of classical learning, but this was not universal, and it was not specifically about the Earth's shape. The real conflicts between science and religion in history have been more specific and more contingent than the broad clash suggested by the flat Earth myth. Specific discoveries and theories have sometimes challenged specific religious beliefs. These conflicts were real and worth studying. But they were not a grand universal conflict between faith and reason. They were particular historical events with complex causes and effects. The medieval period also demonstrates that knowledge can be preserved and transmitted even in the absence of modern institutions and technologies. Medieval monks and scholars copied manuscripts by hand. They passed text from monastery to monastery. They read at cathedral schools and early universities. This was slow and laborious, but it worked. Classical knowledge survived the fall of the Western Roman Empire and the fragmentation of European political authority. This is remarkable. It tells us something about human commitment to learning and knowledge, even in difficult times. What remains true is that the medieval period did experience significant disruptions and losses of knowledge compared to the Roman Empire. The network of education and communication that had existed under Roman imperial authority fragmented. Many works that had existed in the classical period were lost. It took centuries of recovery and reconstruction to rebuild the intellectual network that had existed in the Roman Empire. But this process of loss and recovery doesn't mean that medieval people thought the Earth was flat. It means that the preservation and transmission of knowledge is a complex process, vulnerable to disruption, and that rebuilding an intellectual tradition once it's been damaged takes time. The modern world has its own versions of the flat Earth myth. We tell stories about how ignorant our ancestors were, how much more we know, how much we've progressed. Some of these stories contain truth. We do know more about the physical world than medieval people did. We have better tools and methods. But we also risk repeating the same pattern, creating myths about the past to make ourselves feel superior, inventing false histories to support narratives about progress that serve our current purposes. Understanding that the flat Earth medieval world is a myth should make us more cautious about other historical myths we might be repeating without examination. It should make us more careful about the narratives we're told about the past. It should encourage us to ask, what is this story doing? Who benefits from believing it? What evidence supports it? What are we using this myth for? The real lesson of the medieval understanding of the spherical Earth is not that medieval people were superstitious fools who believed the Earth was flat. The real lesson is that knowledge is more complex and contingent than simple narratives of progress suggest. Medieval scholars had accurate knowledge of the Earth's shape because they had access to texts that explained it logically, and because they engaged seriously with those texts. But they lacked knowledge of what was actually on the Earth, because they didn't have the technology or opportunity to explore it. Progress in knowledge isn't a simple linear process where ignorance gradually gives way to enlightenment. It's a messy, complex process of transmission, loss, recovery, and discovery. It involves people working with the tools and opportunities available to them, making mistakes, building on previous understanding, and occasionally discovering things that overturn previous assumptions. Medieval scholars worked within this process. They did the best they could with what they had. That's all any generation can do. The flat Earth myth persists because it's useful. It tells us a story we want to believe about ourselves, about how far we've come, about the triumph of reason over superstition. But the actual history is more interesting. Medieval people knew the Earth was round because that knowledge had been established in the ancient world and transmitted through the medieval period. What they didn't know was what lay beyond the known world. Discovering that required technology, courage, and luck. Columbus had the courage and benefited from the luck. He didn't have to disprove a flat Earth consensus because no such consensus existed. The persistence of the myth also demonstrates something important about the power of narrative and storytelling in shaping how we understand the past. The most emotionally resonant story, the most useful story for current purposes, often wins out over accurate history. This happens not through deliberate conspiracy, but through the simple fact that compelling stories spread and stick in memory more easily than complex truths. Understanding this should make us more thoughtful consumers of history, more careful readers of historical narratives, and more aware of our own tendencies to believe stories that make us feel good about ourselves. The medieval world deserves to be understood on its own terms, not as a dark foil against which to contrast the modern world. Medieval scholars engaged seriously with knowledge. Medieval institutions preserved and transmitted learning. Medieval Christians integrated classical learning into their theology. These facts don't make medieval people identical to modern people, but they do make them worthy of respect and careful study. And they certainly make them less deserving of the contempt embedded in myths about flat Earth, believing medieval superstition.